this video, we will discuss the citizen science definitions and principles in a bit more detail, to then dive into the reasons for implementing citizen science as a scientist. What is the added value of citizen science? And when you involve citizens into your research, what are the options for you to do that? Those are questions we aim to answer. Let's start with the different definitions for citizen science. When you look at them closely, you can find similar keywords that recur. Here I group them together when they compare. You can see that they describe citizens also as individuals, lay people, volunteers. You can also come across non-professionals or amateurs. These words seem synonyms, but depending on the context, they can give a different connotation to the definition. For example, the meaning of a layperson according to the Collins Dictionary is a person who is not trained, qualified, or experienced in a particular subject or activity. Theoretically speaking, this would mean that I myself, schooled in water management, would not be able to join a citizen science research about water management because I don't qualify as a layperson. You can furthermore notice that I grouped participation and involvement together, and after that, collaboration and partnering. The way you describe how you work together with citizens immediately defines things like hierarchy and the way of realizing the research project. We will get back to this later. Finally, all definitions agree about the word scientific, whether it's a scientific method, question, or research. This is important because indeed, whatever you create with citizen science, it should uphold scientific standards. What is often not written, but implied, is that within citizen science, the role of citizens is at least an active one. They are actively adding to the creation of new knowledge. This means a survey collecting existing but scattered or unshared knowledge is often not included as citizen science. And being, for example, a patient or research subject in health research does not automatically make you a citizen scientist. If you would help in any way to also observe how yourself as a patient, you become an active player and the situation changes. The active involvement is, however, definitely part of the 10 principles. You may have seen it yourself, but the 10 principles are on its own already a way to define citizen science. For example, when explaining what citizen science is, you can be sure to say it is a research approach of its own, as mentioned in Principle 6, with a science outcome mentioned in Principle 2. For the second principle, discussions still exist whether a scientific outcome means a peer-reviewed article or other output as well. In addition, the 10 principles can be used as guidelines for good practice. In the next lesson about participation, we will look closer into Principle 3, 5, and 9. And the lessons about responsibilities follow from Principles 7, 8, and 10. And finally, Principle 4, about the stages of or roles in the scientific process, will be discussed in this video. But before we do that, we first investigate the reasons for implementing citizen science. Citizen science is definitely not always an applicable research method. Therefore, the first thing to do is to decide whether it is a method that fits your needs. To do this, you need to reflect on whether the benefits of citizen science give the value that you need and reflect whether the drawbacks are not too much of an issue. Furthermore, it is very important to realize the goal of applying citizen science because it will influence the design of the research project. Benefits for citizen science can generally be categorized related to data and research or towards society, the impact your project can attain or the level of awareness you can raise. Drawbacks are, among others, that citizen science is very often time-consuming and not per definition cheaper, and there is a chance of lower precision or less grip on what the final results will be. We will look a bit closer at the benefits, as it will relate highly to the goals you will have for implementing citizen science. The value of citizen science for a scientist, and thus the reason to implement it, can be numerous. The first 3 reasons are directly related to the data or research results. Citizen science can be in numerous ways can in numerous ways increase both the spatial and temporal scale of data collection or processing. Also, sometimes you need information that can only be reached or gathered when citizens are involved, like, for example, what happens on private territory, like people's gardens. And finally, in the end, people are still far better than machines in unraveling complex structures. You can create more brain power by including more and other people. Applying citizen science often also has so-called societal benefits, which are the final 5 listed here. When citizens are directly involved, you often can have a direct impact in society. For example, because you work on relevant questions, because people see the relevance to join, or because they help to improve the research question. Furthermore, they might even bring in the issues that led to the research question itself. Then, there are more high-level reasons like increasing scientific literacy among society as a whole, by showing the value of research and because they learn to apply scientific methods. Also, for your own scientific research topic, it can be very valuable if there is increased education about and attention for the subject within society. Of course, which benefits you can reach depend also on how you cooperate with citizens and in which steps of the scientific method they collaborate. For this, we should make several things clear. When including citizens in their research, some people start referring to the input from citizens as something they used. Let's use citizens to do this or that. However, citizens are not to be picked out like you would pick out anything you need in a shop. They have a mind of their own and are no tools to use. You can, however, collaborate with citizens. And often, as you also already saw in one of the definitions of citizen science, the collaborations can be bigger and you can include governments, NGOs and other organizations if this improves the results of the project. And finally, be aware that you will apply citizen science from a scientific perspective, meaning citizens can also apply citizen science and will often do this in a different way and with different goals than scientists do. When you then decide to implement citizen science, you need to consider in which stage of the scientific research you'd like and or need to include citizens. The emphasis on and nature of this participation can significantly affect both the way that projects are designed and the outcomes that projects achieve. Regardless of the research context, project outcomes are influenced by the degree of public participation in the research process and the quality of public participation as negotiated during project design. We will dive into this second aspect in the next lesson. For the first, we want to distinguish 3 methods for describing the level of engagement. In the supplementary material, you will find the papers explaining these methods. Hackley, one of the more well-known methods, which is often mentioned, distinguishes 4 levels of engagement. The first level is called crowdsourcing, where citizens function as sensors or join in volunteered computing. Sometimes even without them being aware, they are helping the research. The second level, called distributed intelligence, engages citizens as basic interpreters or in volunteered thinking. The third level, participatory science, engages citizens to the level of participation in the problem definition and the data collection. And the final level, level 4, is called extreme citizen science, where you include them in the complete research from problem definition to data collection and analysis. Shirk et al., however, defines 5 models based on degree of participation. You can have contractual projects where communities ask professional research to conduct a specific scientific investigation and report on the results. There are contributory projects which are generally designed by scientists and for which members of the public primarily contribute data. Collaborative projects, which are generally designed by scientists and for which members of the public contribute data but also help to refine project design, analyze data and/or disseminate findings. And co-created projects, which are designed by scientists and members of the public working together and for which at least some of the public participants are actively involved in most or all aspects of the research process. Finally, collegial contributions, where non-credentialed individuals conduct research independently with varying degrees of expected recognition by institutionalized science and or professionals. And then finally, a multidimensional framework has been developed by Franzoni, Powitz, and Sauermann to give insight into roles and how actors contribute. The framework profiles projects with respect to 4 types of crowd contributions: activities, knowledge, resources, and decisions. This way they also accommodate machines and algorithms, which increasingly complement or replace professional and non-professional researchers as a third actor. Thank you for the attention and interest, and I will see you in the next lesson where we will continue the questions about participation of citizens.